Hi, everybody. Thank you for watching Multi-Region Deployment Part 2. Today, we're going to be discussing architectural best practices for disaster recovery. So Part 1 of this series talked about needs, challenges, and approaches for multi-region deployments. And some of the reasons you might want to do that would be, latency reasons. You want to reduce the latency for your end users. You might have some business requirements, such as compliance reasons, where you might need to have multiple regions in your architecture. And then the final one is disaster recovery, which is what we're going to be discussing today. Here's what we're going to be going over. We're going to just kind of review disaster recovery at a high level, and then we're going to talk about some disaster recovery strategies. We're going to roll into some best practices for architecting disaster recovery strategies, and then we're going to wrap up with a reference architecture walkthrough of a serverless active-passive workload where you have the ability to fail over to a disaster recovery region. So this reference architecture is an AWS solution that you can deploy into your own account. The source code is available as well on GitHub, so you can tweak as needed. So let's talk about what disaster recovery is. So at a very high level, disaster is any event that impacts the ability of your organization to do its business. So a disaster recovery scenario, a disaster in a disaster recovery scenario would be something like a natural disaster, a flood or an earthquake that has impacted a data center, or maybe a technical failure like network or power connectivity. Also, a disaster could be, human error or a malicious user has deleted something. That's also a disaster that we need to plan for because things like this do happen. So one thing disaster recovery is not the same as high availability. They're related and they share similar best practices, but disaster recovery focuses on recovering your entire workload. High availability is more about ensuring the individual components in your workload are available for your customers. Disaster recovery is part of a larger business continuity plan. So it's not something that needs to be thought about in isolation. Disaster recovery, is just one piece of the puzzle when thinking about your overall architecture and your strategy. So let's just quickly review regions and availability zones. So again, a region is a physically isolated area in the world somewhere that consists of multiple availability zones. So an availability zone each individual availability zone is a physically isolated data center that has redundant power, networking, connectivity, traffic between availability zones within the same region is encrypted and has high throughput, low latency connectivity. So, think about single or double digit latency between those availability zones. So workloads that are spread across multiple availability zones within the same region are going to be better isolated against things like power outages or a lightning strike that impacts the data center, because those availability zones are physically isolated data centers, but they're all connected within the same region. So a lot of reliability goals for a workload can be satisfied using a multiple availability zone strategy within a single region. So if you want to take it a step further, AWS provides kind of an advanced disaster recovery scenario that you can, disaster recovery tool set that you can use to increase the durability even further by spreading your workload across multiple regions. And again, sometimes you might do this to satisfy maybe a regulatory requirement. So let's look at disaster recovery. Let's just kind of go through a couple of examples to learn more about what disaster recovery looks like. So you see here in the graph, time goes from left to right, and you'll see that on the left-hand side, I'm periodically making backups of my data. Then all of a sudden, there is a service interruption in the middle. So that gap between my latest backup and when I had a service interruption, that data, there's going to be some data loss there. And I think everybody has probably experienced a situation where maybe I've been writing a document on my computer and it's been a while since I saved, and then my computer has an issue and crashes, and I've lost a lot of progress. So that is data loss that you want to plan for when you're planning for your business. It's the same sort of concept. So when we're talking about disaster recovery, we want to define something called RPO. So RPO, put simply, is what's the maximum amount of data loss that's acceptable to my business, and that will drive how frequently I need to back up my data. So think about, different workloads within an organization, different components might have different RPO targets because their different workloads are handling different things. So you really want to think about what are the different pieces of my overall workload? Can I define RPO differently? Can I plan for disaster recovery individually? Similarly, on the right-hand side, there is a period of time between when a service interruption happens and you've actually recovered your workload, you've recovered from that disaster, and that downtime in between is what we want to measure using a metric called RTO. This stands for Recovery Time Objective. If I didn't mention it before, RPO means Recovery Point Objective. So Recovery Time Objective is what is the maximum amount of time that's acceptable for my service to be down when there's a service interruption. So again, just like RPO, this is something that needs to be defined organization to organization, or perhaps even workload to workload. You need to identify the different pieces of your application that need to be protected. You need to run a business impact analysis on your workload. And that could be something as simple as literally how much money is lost to my business when my application is down. That will determine what my RTO and RPO objectives are. How much data is acceptable for me to lose in the case of a disaster. Certain workloads, maybe that data is easy to regenerate, and I don't need to necessarily be super worried about backing it up because I can regenerate it if needed. So again, it's going to be a case-by-case basis. Sometimes compliance considerations are going to be a factor here. Some industries require you to have backups stored across multiple regions, for example. So when we're talking about thinking about different disaster recovery strategies, there's always going to be something of a trade-off between the cost and the complexity or the risk that I'm mitigating with my disaster recovery strategy. Think about it as something like insurance for your home, right? You can pay a very high premium, and if the event that something happens, you're covered, and but you do pay a higher premium for that to have that lower level of risk. It's kind of the similar concept here, where as I think about what are the needs of my business in terms of what RPO and RTO objectives do I need to hit, I might pursue a different disaster recovery strategy than if those targets were a little bit looser. Similarly, I might, the impact to my business might be such that, it's actually going to cost me more to architect a disaster recovery, robust disaster recovery strategy than it would be the impact of maybe taking a little bit more time to recover from a backup, from a disaster, sorry. So that trade-off, eventually you will hit a point where those two converge and you've satisfied your risk tolerance and your cost concerns are mitigated, and that's where you should really be thinking about what disaster recovery strategies kind of fit right in that sweet spot, and then we can take it from there and look at picking the appropriate strategy. So within the cloud, there are some great features that are native to the cloud that'll make this a little bit easier. So in the cloud, there's no upfront hardware investment. You don't pay for peak performance only when it's not being used. So in your disaster recovery region, you might be able to provision, smaller sized instances or just less total number of instances. You're able to do more automation in terms of your testing or your infrastructure deployment using something like CloudFormation or CDK, and you just have less IT overhead and generally easier setup that the cloud provides. So we're going to now move in and talk about some different disaster recovery strategies. And as to kind of frame this section of it, I'm just going to talk about a hypothetical e-commerce website. Let's say I run a website where I sell dog treats that I make homemade. Right. So in my dog treat website, I have two microservices. I have a transaction service that allows my users to view my inventory, see the prices, place orders. And then I have more of a social service where I allow my users to upload photos of their dogs enjoying the delicious treats that I make. And then those users can share those photos on my site, and other users can add comments to them and whatnot. So as you might imagine, there's in those two examples, the transaction service is much more mission critical to me. That allows me to actually serve the customers, let them make purchases. And the social services is, while important, maybe not as important as the transaction service. So let's take a look at the architecture very briefly. So on the left-hand side here, you'll see the two microservices, my transaction service and my social service. And I'm using Route 53 as my DNS. So when everything's running as normal, 100% of my traffic is going to region 1, which is my primary region, and I'm using weighted routing in Route 53 to send all my traffic there. Now, if a disaster were to happen, one disaster recovery strategy that we're going to talk about is called backup and restore. So what backup and restore allows me to do is I will back up the pieces of my data that are most important to me in a disaster recovery region, and then I will restore my infrastructure in the secondary region. So you see here on the graph, I'm using Aurora Global Databases to have a replica of my data, read replica in the secondary region. And if a disaster happens, I still need to provision the infrastructure for the rest of my application. So in here, I've got some EC2 instances, maybe some other supporting infrastructure that I would need to provision. But my data is available, and I can go ahead and provision those resources. Again, using something like CloudFormation makes it easier to do that in a repeatable way. So I'm going to do that, but it's going to take me a bit of time to provision that infrastructure and use auto scaling or set the capacity that's needed. So another strategy that we like to take a look at is something called Pilot Light. So in the Pilot Light example, you see here I've got the other supporting infrastructure available in the disaster recovery region, but it's not currently turned on, and it might be not scaled to the fully scaled to handle production load. So in this scenario, I'm going to reduce the time it takes me to recover because I just need to spin up those instances and have them start, and then I can change the routing policy to send traffic for my transaction service to the secondary region. But again, you'll see here that I need to take the time to start those instances, wait for them to start up. I might need to do that manually, for instance. Another strategy, is something called warm standby. So warm standby is similar to the Pilot Light example with a couple of changes. So in warm standby, I've got a scaled down version of my entire infrastructure always running in the secondary region. So at any moment, that region is ready to start accepting requests from my production users. So this will allow me to maybe use a failover routing policy in Route 53 that will allow Route 53 to automatically start directing traffic to my secondary region if health checks start failing in my primary region. So again, you'll see here the difference being that this infrastructure, A, is more than just that critical core of the transaction service, and it's also always running it ready to accept traffic, but just in a scaled down state. So maybe once the traffic starts hitting that secondary region, auto scaling will actually scale up that infrastructure to meet the production traffic, but it's less that I need to do manually once I'm faced with a disaster scenario. And then the final one is active-active. So active-active, this basically means that my workload is actively running in multiple regions, and my production traffic is split between those two regions. So in this scenario, I'm using latency-based routing in Route 53 to route my users to the region that will offer them the lowest amount of latency. And that at any given moment, if one of those regions experiences an outage, that the opposite region can start receiving that traffic immediately because it's already scaled up and it's ready to receive traffic. It already is receiving traffic from normal operation. So here you can see as we move from left to right, from backup and restore over to active-active, you can see that I'm increasing the complexity here because I'm adding more resources in my secondary region. There are added complexity to deploying infrastructure across multiple regions. I'm incurring more cost because I'm having resources running in the secondary region. But at the same time, I'm reducing my risk because as I go from left to right, the time it takes me to recover is in an active scenario, that might even be a matter of seconds, if any time at all. But the trade-off is that you increase complexity and increase cost. Things like, again, infrastructure as code make it easier to deploy your infrastructure in multiple regions. There are great service features that make this easier. We're going to talk about them in a little bit. And we're going to see an example of a warm standby in the reference architecture. So let's talk about some best practices for designing a multi-region disaster recovery strategy. Again, just as a reminder, it's possible to architect a highly available and a resilient architecture in one region using a multiple availability zone strategy. But if you've determined that you need to pursue multiple regions, these best practices will still benefit you. So the first best practice is to interrogate your workload. So I like to think of it as interrogating my workload early and often. So as early as possible when you're initially designing your architecture, you want to be thinking about disaster recovery. What are my RTO and RPO goals that I need to hit? What service features or what services in general, what architecture decisions can I make to facilitate me hitting those goals? If you're doing that early, you're going to be better positioned to react and to design a robust strategy. And then even if you've already architected your workload and you've got disaster recovery planning in effect, you still want to revisit your disaster recovery plan periodically and just make sure, are you taking advantage of the latest service features? Maybe there's a new service or a new feature of an existing service that'll make something easier for you, or just your team has grown in their experience with using AWS and know a little bit more about how to architect something. So maybe there's some new tricks that you can take advantage of. There's also one of the things I like to mention too, as just a kind of a reminder, if you've used service quotas and updated any service quotas in your primary region, you want to make sure that you update those quotas in the secondary region as well. Because the last thing you really want to be dealing with in a disaster scenario is you've executed on your disaster recovery plan, everything's working, and then all of a sudden you start hitting limits that you had already accounted for in your primary region. The second best practice is to enable detailed monitoring of your workload. So you want to monitor all the components of your workload, as many components of your workload as possible. You want to define and calculate metrics that will be indicators to the health of your workload and maybe be early warning signs that there might be some degraded performance, or things that could lead to a subpar experience for your customers. If possible, you want to proactively send notifications based on the result of these metrics to people in your organization that might need to take action in the event of a disaster in effect, or one that looks like it might happen soon. Or maybe you can use these metrics to automate responses in your disaster recovery plan. So if you remember when I talked about the warm standby disaster recovery strategy, I was able to use failover routing in Route 53 to automatically route my traffic to the disaster recovery region when I started failing health checks. It's kind of the same concept here. And then finally, we want to test our disaster recovery plan as often as possible. We want to make sure that we are meeting our RTO and RPO objectives when we execute our disaster recovery plan. So think about a disaster has impacted your organization, you're experiencing an outage, and you run your disaster recovery plan, and then you realize that you're not hitting those goals that you had laid out. If you remember, those goals came from a business impact analysis, and you've done some calculations to identify the perhaps monetary impact to your business of an outage. So and you've designed accordingly. So if your disaster recovery plan is not hitting those goals, you're not doing yourself any favors. So if you can test your disaster recovery plan, you'll identify things like the backup integrity, the integrity of your backup data. Are you able to actually use the backups you're making? Are there any sections of your code that might have something hard-coded that's referencing a different region or something like that? Those little gotchas that you don't want to be discovering when you're in the middle of a disaster recovery event. I want to talk about backing up our data, since as you saw from the disaster recovery strategies, backing up our data is such a core component to a disaster recovery strategy. I just want to highlight a couple of managed service features that I think are worth mentioning. The first is the AWS backup service itself. So the AWS backup service allows us to centrally manage backups for things like EFS, DynamoDB, RDS, and more. You can set schedules in accordance with your your RPO objective for how often you make those backups. You can then also set retention policies to clean up backups that are no longer needed. So if I have a backup that is a few weeks old and I've already since made a new backup, I don't need to store the old backups, for instance. You can use retention policies to clean those up. I also want to talk about DynamoDB. So DynamoDB has a couple of features that we're going to look at in the reference architecture. So the first one is global tables. So global tables allow us to add replicas in multiple regions, and DynamoDB will take care of asynchronously replicating all updates to the table in the multiple regions. Global tables are also multi-active, which means that you're able to make writes locally in any region, and DynamoDB will replicate that to all other regions. The other one that I want to mention for DynamoDB, and again, this point-in-time recovery is the feature, and it's not unique to DynamoDB, but its point-in-time recovery allows us to create a continuous rolling backup and allow us to recover to any point in time in a 35-day window. Other services like EBS and RDS and Aurora also have point-in-time recovery. Just one, since we're talking about DynamoDB, I'd mention it here. Finally, we also have S3. So S3 we're going to be using in the reference architecture as well. And S3 has a couple of features that are great for backing up our data. The first is object versioning, and that will allow us to protect against accidental overwrites or deletions of objects. Similarly, point-in-time recovery in DynamoDB helps us to mitigate that concern as well. And we're also going to be using cross-region replication in the reference architecture to asynchronously replicate data from one region to another. Cross-region replication allows us to control at the bucket, prefix, or even individual object level a replication rule to automatically replicate data from one bucket to another. And then really quickly, I wanted to highlight a couple of AWS solutions that, again, these are publicly available. You can deploy them in your account, and the source code is available. That these might help in disaster recovery architecting. The first is Operations Conductor. Operations Conductor allows you to configure cross-region or cross-account resource management automation. You can set a time or schedule-based trigger or even a manual trigger, and then set a target tag the resources that you want to take action on, and use a AWS Systems Manager automation document to perform operational tasks on those resources. You can reduce your operational complexity and have an easy-to-use single pane of glass UI to manage those operational tasks. The second is cross-region replication monitor. Since we're going to be talking about cross-region replication in the reference architecture, I wanted to also mention this solution. It allows us to automatically check the replication status of objects and provide near real-time metrics and failure notifications on those replications. So let's move into talking about the reference architecture. So this is the architecture that we're going to be talking about today. Again, this is a serverless implementation of an active-passive architecture. One thing I want to mention about this, it has the concept of an application state. And there's three possible states that can happen in this architecture: active, fenced, and failover mode. So active mode is kind of our business as usual. Everything is running as normally. We are targeting our front end is configured to target our resources in our primary region, and all operations in the write operations in the application are supported. The second is fenced mode. So fenced mode is, think of it as read-only mode. What we would use fenced for is we've identified that there's some degradation in our primary region, but we're not yet ready to fail over. Maybe I need to perform some disaster recovery tasks, or I need to wait for a backup to get copied over to the disaster recovery region. So I'll flip my application into fenced mode. All traffic will still be routed to the primary region, but the application on the front end will block all write operations. And then finally, I have failover mode, and very similar to active mode, but all operations are supported, but I am targeting the disaster recovery region at that point. So the reference architecture will deploy an AWS Amplify application written with React. The application is hosted in an S3 bucket and distributed with a CloudFront distribution. And the application will react to the state of the application, to the state of the application, active, failover, or fenced. It has logic in it. It also has logic in it to query the routing layer for the current state of the application. So this is where on initial load, it will query the application state, and before doing any write operations, it will query the application state as well. The routing layer is deployed using 2 regional API gateway endpoints, and the front end has logic to reach out to the disaster recovery region's API routing layer endpoint if it can't get a response from the primary region. And then finally, we have our data storage in the back end, and this is where we're going to be using cross-region replication and global tables to asynchronously back up our data to the secondary region. So now we're going to go through a short demo of the sample application. So let's go ahead and take a look at that. So I'm going to first log into the application here. So again, when I log into the application, what's happening is the application is going to reach out to the routing layer and is going to request the state of the application. So when the routing layer responds, the routing layer is going to respond saying we are in active mode, and my front end should configure itself to target the primary region. I've chosen US West 2 in Oregon as my primary region. So you'll see here at the top left of the screen, that is the region that we are targeting. So I'm going to go ahead and upload an image. Again, this is kind of modeled across that social service example that I gave before. So I'm going to upload an image. And that image is now stored in the object layer, object store bucket in my backend infrastructure. So let's flip over to the S3 console, and you'll see here I'm in the Oregon region, and I'm going to refresh, and I'll see the new object that has been placed there. So that there's my object that has just been uploaded representing that image. That's a randomly generated UUID, and again, I am in Oregon here. So now I'm just going to flip over to the secondary region's object store bucket, and we're going to just verify that here in Tokyo, we've got our secondary region bucket. And you'll see that cross-region replication has replicated that object for me in the secondary region, same object key. Asynchronously behind the scenes, I didn't have to do anything other than configure that replication rule. And again, that replication rule is deployed by the solution itself. So let's go ahead and add a comment to the image. So again, I am in the primary region. So I'm making a comment. That comment is going to be stored in DynamoDB in the primary region. So let's flip over to the DynamoDB console and have a look. I'm just going to tab over. I am in Oregon, and I'm going to just show the key value store table, and I'll take a look at the item that was just created. So there's my item. So if I'll click on it, and you'll see here, there's the comment I just made, and there is the primary region as my update region for this item in the global table. And you see that photo ID matches the S3 object ID. So similarly to what we just did in S3, we're going to look at Tokyo, the DynamoDB table in Tokyo, and we'll take a look, and you'll see that that item has been asynchronously replicated to the replica table in Tokyo. You'll see there, it's still showing that the update region was Oregon, but we are looking at Tokyo, and there's the comment that I made. So now you'll see that I have asynchronously backed up the data of my application. My application is running in normal mode, but let's simulate changing the state of the application. So off screen here, I'm updating the state of the application. The application state is now in fenced mode. So I'm going to see how the front end will react to the state being changed. So you see here that message is saying, please try again in a few minutes. Again, fenced mode is our read-only mode. We're still targeting the primary region, but we are not allowing write operations. And that's because there are some failover activities that we need to take place. So we're doing those now, simulating what that being done. So again, similarly with comments, we're blocking comments for the moment because we are performing some failover activities. So now I'm changing the state of the application to be failover, and you'll see that we get similar message but slightly different direction for the user. So now the front end is prompting me to refresh the application to enable photo uploads. And then similarly with comments, I'm going to get a similar message saying, please refresh the application. So let's go ahead and refresh the application. And now you'll see in the top left corner, I am now targeting backend resources in Tokyo, but my image is still available because, again, cross-region replication has replicated that image for me. And DynamoDB Global Tables has replicated that comment, and I'm able to now still see that content that was generated in the primary region. And now I'm also able to make a comment while my application is targeting the disaster recovery region. So let's go ahead and flip over to DynamoDB, refresh really quickly. I'm in Tokyo. So let's refresh really quickly. There's my new comment, and you'll see the update region now is Tokyo. And there's the second comment that I made there. And we'll take a look here. That comment has been asynchronously replicated to the global table in Oregon. Remember, global table is multi-active, allowing me to write in both regions. So you'll see that that comment has been uploaded there, replicated there, sorry. And here I am just uploading a second image to the application. And this image will go to the secondary region's object store bucket. And similarly, you'll see there that that image is just basically the architecture diagram that we saw before. And just like before, I can add a new comment. So you'll see here, I still have essentially full functionality in my front end and in my application, even though my application is now failed over to a disaster recovery region. So that was cross-region replication and DynamoDB Global Tables in action, enabling me to do that. So we're going to wrap up with a couple of references. I mentioned part one of the talk, talked about needs, challenges, and approaches for multi-region deployments. If you haven't checked that out, I highly encourage to view that, that part one of this series. Also, at reInvent 2019, there was a great talk on backup and restore and disaster recovery solutions with AWS. I encourage you to watch that talk. It's very good. Also, the AWS well-architected framework, there's a ton of great information there. I highly recommend having a look. Specifically, the reliability pillar is relevant to what we talked about today, so I'd encourage you to check it out. And then finally, there we've got the multi-region application architecture, reference architecture that I just demoed for you. So that link there will take you to the landing page. You can install it in your own account, or you can get a link to the GitHub repo and make any changes you want. Once again, thank you so much for watching. I really appreciate taking the time. And if you have a moment, please complete the session survey. Thank you again.